So in this video, I'm going to talk about periodic table. Uh, it's a beginner guide to begin with how many elements, periods, groups, and blocks are here and why and how are they arranged. So let's move on the very first slide. This is how a periodic table looks. It has many elements arranged in the forms of like horizontal lines, as you can see over here, and vertical columns like here, and they are colored, which means each of them might have different properties than the other. Okay. So, what is a periodic table? The periodic table is an arrangement of chemical elements in the form of a table to reveal their pattern of properties. Periodic table arranges the elements in the form of a table, but this arrangement is based on something. And what is that? The increasing atomic number. It means the elements which have less atomic number, they will be at the top of the table, and those having higher atomic numbers, they will be at the bottom of the periodic table. So arrangement basis, this is very important point. Increasing atomic number. So, and what is atomic number? The number of protons in the nucleus. This periodic table is also termed as modern periodic table, and it was developed by Henry Moseley in 1913. Before Moseley, there was another scientist who initiated like the arrangement of elements in the form of table. He was Mendeleev. But there was some sort of difference between these two periodic table, and let's throw some light on that. Basis, Mendeleev arranged the elements on the basis of atomic mass, and Moseley, he arranged it on the basis of the atomic number. Mistakes, some elements were in the wrong order, but in Moseley's periodic table, these mistakes were fixed and the position of all the elements were like arranged accurately. Used today? No. Mendeleev periodic table is outdated. However, Moseley's periodic table is still in use and in practice. Basic features of periodic table. The current periodic table has 118 known elements whose atomic masses and numbers are well defined. 4 blocks, SPDF, 7 periods, and 18 groups. Periods are the horizontal lines, as you can see here, and groups are the vertical columns. Okay. Elements in the periodic table. 118 elements of the periodic table are classified as metals, non-metals, or metalloids. Here you can definitely see all the metals here, they are colored as red. And all the metalloids along this ladder line is differentiating the metals and the non-metals. The yellow elements are metalloids like boron, silicon, germanium, and non-metals. All these blue along with hydrogen, these are classified as metals. And how do we define a metal? By its ability to donate electrons and to form a cation. So metals tend to form cations, they tend to form positive ions, and non-metals, they tend to share or like some sort of gain electrons, and they gain negative ions, they become negative ions. Periods. There are 7 periods in the periodic table which are represented as horizontal rows. So this is the very first horizontal row. It is the shortest period with only 2 elements, hydrogen and helium. Then the second horizontal line, then the third, fourth, fifth, and sixth, and then seventh. Sixth and seventh, these are the longest periods of the periodic table. Elements in the period. Elements in a period have different chemical properties. It means if an element is present here and if an element is present here, they both are in the same period, but they do have different chemical properties. This is an overview of the periods. Like the period 1 has hydrogen and helium, and so on. Period 3 has the elements from sodium to argon, and period 6 have element like from cesium to radon. Groups, vertical columns like this, these are the groups of the periodic table, and there are 2 types of notations to divide group. The very first is the 18 group notation. It means this is the group number 1, group 2, group 3, so on. Group 17 and then group 18. And this is the second notation in which the 18 groups are divided into two subgroups. Subgroup A, it contains all the normal elements, and subgroup B, it contains all the transition elements. So here in the center we have subgroup B, at the end, okay, and these block which are like dark in color, these are the normal elements or non-transition elements, and they constitute the subgroup A. Both notations are fine, and sometimes you need to mention both. For example, if I say chlorine is present in group number 17, this is a right statement, and if I say it is present in group number 7A, this is also something accurate. So both can be used simultaneously and for accuracy. Yeah. Blocks, there are 4 blocks in the periodic table, like S, P, D, F. And how do we define that this is like, suppose sodium is an S block element, because in sodium the valence electron is present in the S block. And if I say carbon is a P block element, it means the valence electron, it is present in the P block. If we like look at the electronic configuration of carbon, its the atomic number of carbon is 6. It means 1s2, 2s2 and 2p2. So these two valence electrons, these are present in the p subshell. Okay, p subshell. So it means it is a p block element. All the transition metals are here in the D block. So this is how elements are organized into blocks on the basis of the valence electrons. Hydrogen is an S block element. Similarly, helium is also an S block element. These are the atomic numbers of first 12 elements of the periodic table. You need to memorize these in order to have a better understanding of the inorganic chemistry or maybe the atomic structure. So the atomic number of hydrogen is 1, and for helium it's 2. For lithium it's 3, for beryllium it's 4, boron 5, so on, sodium 11, magnesium 12. So you must memorize these. Here's a question for your brainstorming. I previously said that why the chemical properties are different in periods. Why so? So you need to brainstorm why chemical properties are same in the groups and different in the periods. And if you have, like, you need to mention this answer in the comment section. And if you want me to elaborate any of the concepts regarding the periodic table, you may contact me, or you may like post it in the comment section down below. Thank you.